off we go. So here's our shape, and then we want to know, where'd it go? The red trapezoid is what fraction?
I don't know.
What's that?
Because it says to fill it, I guess it would be the same size though, with one trapezoid, two blue rhombuses, and one green.
Oh, they said to refill it. Okay, sorry, I missed that part. Now fill the shape using one red trapezoid, two blue rhombuses, and one green triangle. Okay. One red trapezoid. All right, so I didn't do that part. 1, 2, 1. Wrong page. Where'd I go? Ah, there we go. So one trapezoid. Oops. Two of these guys. And one green, is that right?
Mm-hmm.
Okay, so whoa. Let's see, how are we going to do that? That's going to have to turn. Anyone wants to instruct me in the right direction.
I have problems with that too, because I
You put the
visualize it without.
rhombus and the trapezoids the same way as before. Or if you do it that way, then you just put the green triangle on the other side.
So so you're saying there's more than one way to do it?
Yeah.
Okay. Yeah, it's nice to have these toys with them, and we're going to use these toys a lot. So some of you may decide after today to take a bunch home with you, because trying to draw without them can be a problem. Okay, so there's the same shape, but a different collection of figures drawing it. But either way, we can still determine what fraction that red trapezoid is. And one way to do it is to have kind of a common, this green figure ends up being a common denominator in comparing these guys. And so if I drop that in there, I put one on the other side. And let's throw one more in up here. So we can see this figure can be broken up into a bunch of little triangles. 1, 2, 3, 4, 5, 6, 7, 8 of them. And so then that little triangle ends up being our common denominator for relating any two of the pieces. So the whole has 8 in it, the red trapezoid has 3, and so it should be 3/8. So finding a common denominator piece is super important.
Can you say that again?
Repeat.
Can you say that again? How you go from 3/8?
Yeah, so the question is, and let me copy this into my notebook and I can draw on it that way, make more sense. There we go. Screenshot it. All right, so here's my whole figure, right? And the whole figure has 8 pieces. We want to know what fraction the red trapezoid is. And the red trapezoid is made up of 1, 2, 3 of those equal pieces. So then we can say the red trapezoid is 3/8 of the bigger figure. Let's call it the figure. Oops. And to do that, we just had to have a piece that everything could be made of. And remember, a fraction is an equal part of the whole. So we have to have something that's all the same size. And those little triangles, they're different colors now, but they're all the same size. Okay. All right, other questions on that? And the same idea of finding an equal piece we can use as a measuring stick to measure all of the other pieces is going to be super important in the next activity. Okay, let us move along. So we get a little bit more work to do with just comparing fractions, and then we'll start working with addition and subtraction. So, nope, here we go. So this activity here, number 2, is guiding us through building a sequence of shapes called tangrams. And there's 7 of them. And along the way, we're building other shapes, but those shapes are kind of transient because, first we had triangle A, but then we cut it up into little pieces. And then we took this triangle here and we cut it into pieces. And then B, it gets chopped up again. It loses a triangle on the edge and it becomes C. But then C gets cut up into D and 5. So along the way, we're losing track of that. So answering some of the questions is going to be a little tricky as we move along. And then ultimately, we're going to finally chop D up into these last 2 pieces, 6 and 7. So if you don't already have all 7 pieces, you want to make sure you have them now so we can start talking about them. Somewhere, let's see, where's my last one? Some files. Production intro. It's got to be it. Last one I got 2. Yep. All right. Oh. Okay. Once you have them all cut up, what I want you to try and do next is put them back together into the original square. And then we'll try to answer some of the questions that are unanswered.
Oh, so sad. That's how long it takes. It's so. My application. I'm 100% sure.
Oh. Huh. Interesting. All right, so hopefully when you get them back together, it looks something like that. Now, I'm not positive, but I'm pretty sure there's only one way to put them all back together aside from switching 6 and 4. And it turns out you can actually build other rectangles besides a perfect square out of this. So if anybody wants a bonus, come back Wednesday with another rectangle or some other really cool shape that you make out of these. So the puzzle that's used a lot is somebody will draw a picture, an outline of something, and then kids are supposed to take all 7 shapes and build the something that somebody drew. And I have a set of like templates you can do that with. So I have a set of wooden ones of these, and then with that wooden set are all these outlines on paper that you can try and put the things into. And it's a fun thing to do. It's really good for little kids. Building up the mental agility. All right, so let's see if we can answer some questions based on this group of shapes. All right. Where does it get interesting? Maybe right here. So triangle 4 is what fraction of triangle 3 that we made earlier? Oh, and another reason I recommended 2 colors is if you cut these shapes out in 2 colors, they're easy to compare to each other, to sit on top of each other.
So 160.
4 to 3
Oh,
to 3 is 1/2. Yeah, if you sit it down just right on triangle 3, so that's triangle 2 there. You got triangle 3.
Oh, I was on.
Oh, you're skipping way ahead.
Sorry.
Oh, right, so never mind.
Yeah.
I'll stop watching.
No, you're fine.
Triangle A.
Is that?
Triangle A. Which one was triangle A?
Wasn't the bigger one?
It was the bigger one, yes. So A is made up of what 2 shapes?
It's 1/2 of the whole square, right?
A is 1/2 of the square, true. But you actually have A in front of you if you put 2 pieces together just right. 1 and 2, if you put 1 and 2 together, that's A. So triangle 4, what do you got, 1/8? Okay.
Wait. So,
So this right here would be triangle A when I put 3 and B together. Okay, or if I put 1 and 2 together, that's triangle A also. So we're taking triangle 4, that little guy right there, and we want to know what fraction of it. So we know what part of 3 it is, right? What part of 3 is it? It's 1/2. And how many of 3s do you need to make this big triangle? 4 of them. Okay. So now how many of 4 do you need to build this big triangle? Nope. 8.
Okay.
Yeah, because I need 2 of them to build 3, and there's 4 of triangle number 3 in here.
Are we doing triangle A, not triangle 1?
Oh, yeah, this is triangle A right here. No. So basically we made 2 triangle A's when we cut the square in half. One of those got cut in half to be 1 and 2, and the other one got cut into lots of pieces.
I thought that this.
Oh, you cut up triangle number 2
Yeah.
instead of, okay, yeah, so
Yeah.
you followed
my
a different
answer-
set of instructions. So your answers are gonna be way off. Yeah, so we were supposed to cut up the other triangle that wasn't cut up. Would you like another square? Yeah, yeah, these directions are a little tricky. All right, so just double checking on that. Let's see, where's my worksheet? Right here. Nope, this one here, there we go. New page. I'm gonna screenshot that thing just to, wrong one, escape. Come on. Let's get rid of this. Sorry, I'm having technical difficulties. So for this one, I liked using 3 as a reference when I was talking about triangle 4 or triangle 6. Because I know that if I drop triangle 6 in or 4, it's half of 3. And then when I flip 3 over here, I can see that the biggest triangle I have is made up of 1, 2, 3, 4 of the 3s. And so if I cut all those triangle 3s in half, then I get 1, 2, 3, 4, 5, 6, 7, 8 triangle 4s. So triangle 4 is 1/8 of triangle A. How about trapezoid C, which is this one right here? How many triangles 4s fit inside of trapezoid C?
6.
6 of them?
5, maybe.
If you cut it off.
Yeah, because 6C is what's left here. If you look back here, B is the big thing. Yeah, so there's 6 triangle 4s inside B. 1, 2, 3, 4, 5, 6. So how many are inside C then? It'd be 5, so it'd be 1/5. Yeah. Yeah, that's another one of those tricky points. So now Emily's going to have to catch up a little because she had the wrong figures there, but did anyone get stuck on any of the other ones moving along that I should jump to right away? I'm not going to do every one of these. I'm just going to jump around a little. Yep.
Number 5.
Okay.
C.
5 is what part of C? Okay.
Or 5C, so triangle.
Oh, 5 is what part of 3? Okay. So here is the idea of using a common measuring device. So what I would do is I would take triangle 4, it's the littlest thing. How many 4s fit inside of 5? 2 of them. And how many 4s fit inside of 3? 2. Yeah, so you could either say 2 to 2 if triangle 4 is your measuring device,
okay.
or you could say just 1 to 1. They're the same size. Different shape, but same size. 1 is okay too. Yeah, I'm in fraction mode, so I'm writing everything with 2 numbers, but 1 is a fine answer also. Yeah.
Pretty much have the right answers as long as it's not asking. Or a little square.
Okay. Because everything else was scaled down by half
Yeah.
of yours. Yeah. Okay. That's good. Yeah. There we go. That's not too bad. All right. How about 6, triangle 6 compared to trapezoid D? What do you
It's going to
think?
be
What is it?
1/3.
1/3, yeah. So trapezoid D is this whole trapezoid, 6 plus 7 combined. And if I draw a dividing line right here, then I get 1, 2, 3 of the same size triangle inside. So 6 is 1/3 of D. Okay, so here is where it starts to get interesting because now we're going to get into the idea of common denominators. And so let's jump down to number 12. The original square is 1 unit. So trapezoid D and triangle 3 can be used to model this addition problem. So the question is how? So what I'd like you to do is get out your trapezoid D and your triangle 3. Get mine out. New page. Here's my trapezoid D. And I also want triangle 3, is that right? Yep. Looks like that's the best shot of it I get right there. And those are not to scale. All right, so we'll try this a little different. Probably can do it from my second slide. Let's copy this. All right, so 3 is what fraction of the whole thing?
And 16
What's that?
of the whole square.
Of the whole square,
Is it
yeah.
1/16?
3 or 4?
3, I think 3 is 1/8. So one way to think about that is you can, of triangle number 1 or 2, there's 4 of them in the whole thing. And 2 triangle 3s fit inside of triangle 1 when you sit them just right. So there'd be 2, 4, 6, 8 of them coming around. So it's 1/8 of the whole thing. And the other shape I wanted to think about was trapezoid B, which is this sucker right here. I'm going to have the right one. Let's see. 5 ones. Trapezoid D, sorry. That is that one. Okay, I had the right one. So this one right here. And what part of the whole is that? So it's got 3 of figure 6 in it. How many figure 6s are in the whole thing?
16.
There's 16 of them, so this would be 3/16. Oops, 16ths. There we go. All right, so if we combine these two pieces together, what do we get? So now we want to take these and combine them. What does combine mean? What does add mean? Not just combine, but combine and count. And you can only count things that are like. So can I say I have 2 somethings? Or 1, 2, 3 somethings? What do I have here?
2 16s and 1 16.
Yeah, so what I have to do is so I'm going to cut these up. I have to again realize how this is 1, 2, 3 16ths, and then I have to rewrite this guy right here as 2 16ths by cutting it in half. So I'm using triangle 6 as my measuring stick here. So now I'm saying that this is really 2 16ths. So when I combine and count them all together, the total is 5 16ths. So the bottom line is in order to add fractions, you have to have a common denominator because you can't count if they're not the same size. And so we just break them all into these pieces that are 16ths. And we can count 1, 2, 3, 4, 5 16ths in the whole thing. So this area is 5 16ths. Questions on how I came up with that? We're going to try this again with other shapes. That's like the whole focus of today, fraction addition. Are there any other questions? So I just picked on a few here, kind of random, kind of not. Anybody else have a question they wanted to ask? Emily, I think you have a question there.
I don't know what you just said, but I had you say we're going to go over that one.
Yeah, I was going to do that one next. Okay. Other questions besides 13? Okay, so next we're going to do 13. So here we're going to consider, let's see, trapezoid B is going to be our whole. So we'll need to isolate that. And then we want to explain how triangle 4 and trapezoid D can be used to model this division problem right here. So first we got to get out those shapes. So I'm going to go get another screenshot. So let's say I need B, D, and 4. All right, so let's see. So B is this one right here. Let's see if I can steal that. Good. And, oh, come on. Come back then. There you go. What was the other one I need? B. No, wait. That's C, isn't it? Did I get that wrong? Okay, B is this big one. I missed. So we'll try that again. E is this big one.
Thank you.
And then BD, what was the other one after D?
4.
4, thank you. So that's B, C was here, D was right here. All right, and then 4. I'm running out of colors. I guess I'll use black for 4. Okay, so I got all of them there. And then the division problem we're going to try and model is 1/2 divided by 1/6 equals 3. 1/2 divided by 1/6 equals 3. So what does division mean? Think back to last term. What were some of our definitions of modeling division? Groups in, yeah. And I think that's probably the one that's going to work here. So what this would say is how many groups of 1/6 are in 1/2. Okay, so then we were told to do some things. We were told that triangle B was our whole. So let me just separate some things out here. So this thing right here is one whole. So what's the red shape then? 1/2. And what is this shape here?
6.
That would be 1/6. So here's 1/6 is what's going into. So I'm gonna, let's see, yeah, I'll draw this on a new page. So what I wanna do is I'm gonna think about long division for a minute. I wanna take 1/6 into 1/2, right? Because I wanna know how many groups of 1/6 are in 1/2. Now to do that, I'm using this triangle right here, and I'm trying to say how many of these guys live inside, oops, that's kind of small. That shape right there. So what if I did that right there? How many of these live in here? There would be 3 of them. Okay, so division means how many of this thing live inside of that thing? And we find that there's 3 triangle 6s inside of trapezoid D. Did I get that letter right? I think I did. And we have a whole nother activity where all we're going to do is that. So if you found this to be on the edge of your imagination today, you're going to get more practice. So if it only made partial sense, don't worry yet. Okay, now we'll get through this. Except we don't need any squares. We'll really seem like this. So the pattern blocks are coming around. Well, you can tidy some stuff up right now. And the pattern blocks that we need are the red trapezoid, the blue rhombus, the green triangle, and the yellow hexagon. So for the next activity, you'll need some of each. And I'm not quite sure how many we'll need yet, so just grab some. We can always get more later.